Okay, question 13. So we've got an integration question. So right away, I'd be thinking to myself, okay, I've got x cubed. If I want to differentiate it, so that's my y, if I differentiate it, pardon me, that's going to give me 3x squared, okay? If I have x cubed and I want to integrate it, remember we add 1 to the power and then multiply by the new power. Okay, just something like that, just to remind me what I'm doing. Okay, and again, you can double check that this makes sense, because you'd say, well, if I integrate this, do I get back to that? Yep, I add 1 and then I divide by the new power. Absolutely, add 1, divide by the new power takes you the other way around. Okay, so yeah, and likewise I differentiate this, I multiply it, get 1, take 1 away. So something like that, just to remind you of what you're doing. Now, we've not got a straightforward integration here. We've got our further calculus because we've got our bracket. The minute you see a bracket with a normal power, say a squared or a cubed, you're welcome to multiply that out and then integrate each time individually. For example, if I've got something like this, okay, I can integrate or differentiate those terms on their own. If I've got something like, say I said that was x over x divided by 2, I would have to then split them up and say, well, that's x cubed over 2 plus x negative 2 over 2, and then integrate or differentiate, and that's fine. But when I've got power to the half, I'm thinking, oh, wait a minute, that's quite tricky how to multiply that bracket out. And that's when we'll use our chain rule. Okay, so just to get you into the question, have a wee think, don't rush in, just remind yourself, what does it mean to integrate, what does it mean to differentiate? And yeah, if it's set out nice, or maybe it's not set up completely nice, but you can set it up for your integration, that's fine. But if you're not able to do that, then you're thinking it's chain rule. And the clue for the chain rule, whether it's integrating or differentiating, is that it's going to be a composite function with a funny power. Usually it's a very big power, or it's a fractional power. Okay? Because we could quite easily, if someone said integrate y is equal to x plus 2 squared, I could just say, well, just multiply that out and then integrate or differentiate it. That's quite easy. But if it's x plus 2 to the power of 5, that would take me a bit of time. So why bother? So first thing I'm going to do here is I'm going to set up my integral to be a little bit nicer, so I'll get it on top. So I've got 5 take away 4x to the negative a half. My computer just keeps pace. And that's dx, fantastic. And now we're ready to integrate. So first thing I would do is I would just write down a plus c, because I know that when I integrate, I'm going to end up with plus c. Okay? Then what I think about is inside and outside. So with the chain rule, you're thinking about this bracket almost like being a term. So if you imagine it, say call it u, okay? I want to integrate u. So what am I going to do? How did I do it over here? I added 1 on and divided by the new power. So if I was just doing it to u or any term, whatever, I would add 1 on and then divide by the new power. That's what I'll be doing. So I'm going to do the exact same thing here then. I'm going to add 1 on. Once that rubs out, I'm going to add 1 on. And I'm going to divide by the new power. Excellent. Now inside the bracket just stays the same. So that's 5 take away 4x. And the chain rule tells us that we need to then divide by the differential of the bracket. Okay. It actually says that to the front on your formula sheet. It reminds you when you've got your trig integration and differentiation rules. It shows you that if you differentiate sine ax, if you differentiate that, you'll end up with a cos ax, because you're multiplying by the differential. But if you were integrating it, it's got the 1 over a, okay, which means you're dividing by the differential. Okay, so if you forget that, it's there in the front of your sheet. Now we just need to tidy this up a little bit. So I'll keep my plus c where it is. I'll keep this bracket where it is as well. Take away 4x. I'm just going to write that as a root, just to remind you that you can do that. So what does this become? A half times negative 4. So half times negative 4 is going to become negative 4 over 2, which is just negative 2. So I'm dividing by negative 2. So it's kind of the same as multiplying by negative a half. So you could say that, or you could say multiplying by negative a half. Doesn't really matter. Yeah. So you could write it like that, or you could say negative a half, 5, take away 4x to the half plus c. Either one is absolutely fine. Yeah, so I just wanted to show you could put that as a surd. But yeah, the most important thing is to remember that you treat this bracket as if it's just a normal term. You don't be confused with if it's a bracket. You're still just doing the same thing on the outside of the bracket. Add 1, divide. That's what's in the red. But then you need to do this divide by the differential. And for 4 marks, really not too bad a question. Because it's a new skill, there's a lot of good marks for it. And also, they can't really change this up too much. Yeah, they're getting you to apply this type of new formula. They can only dress up in so many ways. Okay, so it's a really good question to know. All you need to remember is this new chain rule, kind of reverse chain rule, where you're dividing by the differential. So great question. If you read these, don't lose marks on the plus c as well. That's silly. So make sure you get that. Remember your integral with dx as well. Don't be not writing that. But yeah, like anything with integration, I would start with this. Just remind yourself, tell yourself the story. How do I differentiate? How do I integrate? I need to make sure it's all it's all separate. If I've got a bracket, that's what I'm thinking and using the chain rule. Okay. So yeah, question 13. Hope that's helpful.